Today we're investigating the sign of a function, and we're going to begin by spotting any changes that we can see in the sign of a function. Now, to start with, what is the sign of a function? Well, when we write functions, we normally write y equals something, and there'll be some x's in there, or we write it in the form f of x equals something. So as we look at how a certain function is graphed, where it sits in space, and depending on whether it's above or below the x-axis, that tells us the sign of the function. Now, if y equals the rest of the part here, then y is the function, isn't it? So if y is positive, the function is positive. If f of x is positive, the function is positive. So looking at this graph down here, which is quite a complicated one, we can see that sometimes the graph sits above the x-axis, and other times it sits below, above, above, below, below. Now obviously once it's graphed, it's pretty easy to spot where it's above or below the axis. But how do we spot the points where it might change over? Well, there's a couple of things we've got to think about. We need to start by thinking where it's going to cross the x-axis, and we do that by letting y equal 0 and finding out where these key points are. So on this graph we have x equals a and b as those zeros or x-intercepts. Also, we need to consider whether there's any discontinuities in the graph. Now that's any place that when you're drawing it, you'd have to lift your pen. And there's two reasons you might have a discontinuity. One is there might be an asymptote. For example, there are two vertical asymptotes here, and that's a spot where the graph is not continuous. But it may be that there's some other gap in the graph. For example, this section here comes down and stops with a closed circle on this point, where x equals e. But below here, we continue on as x gets bigger than e, with an open circle showing that that point there is not part of the function, but from there on, it will head along this way in a straight line. We've got another gap here. Now, we need to investigate the gaps, and we need to investigate the x-intercepts, because those are the key points where we're looking for the graph to jump from above or below the x-axis to the other one. Once we know where those points are, the x-intercepts and the gaps, then we need to consider, all right, between those places, is the function above or below the x-axis? Because if we can investigate those points, then we'll know a lot about the graph. So looking here, we can see that we are crossing from the function being positive to negative at this point here when x is equal to a. Then the graph is negative, the function is negative. It comes up to 0, which is neither positive or negative, and stays negative again until it gets to x equals c. Now x equals c can't actually be graphed for this function because it's an asymptote, but it is the key changeover point where the graph changes from negative to positive. So if we're just listing here the places where we change the sign of the function, we've got these two, a and c. Here the graph's positive, and then it's still positive, but at this point, x equals e, it changes from positive to negative. So that's our third and last point. And these are the points in the graph that we can see that there has been a change in sign of the function. And that's a change from positive to negative or vice versa.